Hello students, in our DME class, today we will discuss the design of hand levers and foot lever. The design of hand lever and foot lever are similar, so we will discuss one question and you will understand the design of both the levers. So let's see the procedure. Let P is equal to force applied at the handle, means this is your lever. This is your hand lever actually, and this is force P acting at this point, which is at a distance L from the center of the shaft. L is equal to effective length of the lever. So this is your L. We can say it is effective length of the lever. Sigma T, permissible tensile stress. Tau, permissible shear stress. So first of all, you have to find the diameter of the shaft, D. This diameter of the shaft we will obtain in a similar manner as we have discussed in the couplings. Secondly, you have to determine the diameter of the boss. Boss we can say hub. So D2, which is taken as 1.6 D. So this is your small circle is the diameter of the shaft. The bigger circle, that is D2, is the diameter of the boss, which is equal to 1.6 D. Thickness of the boss T2 is 0.3 D, means the thickness T2 of the boss is 0.3 D. Length of the boss L2 may be taken from D to 1.25 D. So this is L2, the top view of the figure. Length of the boss, it is taken as D to 1.25 D. The diameter of the shaft at the center of the bearing D1 is obtained by considering the shaft in combined bending and twisting. So this is your D1, diameter of the shaft at the center of the bearing. So it is obtained by considering the shaft under bending and torsion combined. So bending we can say P into L, that is load is acting P at a distance L, bending, and torsion you can see P into capital L will be your torque. So equivalent twisting moment will be m square t square under root. Put the values of m and t and you will get this relation p under root l square plus l square. And twisting moment is given by pi by 16 tau d1 cube. The length L may be taken as 2 times L2. So this is your length L and it is generally taken as 2 times L2. These are empirical relations. The key for the shaft is designed as usual that we have done in the coupling. Cross section of the lever near the boss may be determined by considering the lever in bending. So if we see the bending stress, sigma b is m by z. M is bending moment, P into L, and Z is section modulus of a rectangular lever, 1 by 6 into thickness into width square. Width of the lever near the handle is B by 2. So if we see this is the width of the lever, and if from the top we can see this is the thickness of the lever, and width of the lever near the handle is B by 2. These are empirical relations. So this is your hand lever, and similar will be your foot lever, which will be like this. The only difference is the pedal is used in case of foot lever, the foot pedal, your foot plate, and handle is used in case of hand lever. Rest of the design will be same. So let's see the numerical. A foot lever, or we can have a hand lever, is 1 meter from the center of the shaft to the point of application of 800 Newton load. So the load acting is 800 Newton. This P is 800 and distance given is 1 meter. This length is 1 meter. Find diameter of the shaft, dimensions of the key, dimension of rectangular arm of the foot lever at 60 mm from the center of the shaft, assuming width of the arm 3 times thickness. So this is the given data. Tensile stress given is 73, shear stress is 70. So let's start the numerical. Length is 1 meter given, we convert it into mm. Load is 800 Newton, tensile stress and shear stress are given. So first of all, you have to find the diameter of the shaft as we have discussed in the couplings. So diameter of the shaft, let's say it's small d, and torque is P into L, that is load into distance. We have calculated torque, and torque is also pi by 16 tau d cube. Put the value of shear stress and you will get the diameter of the shaft 38.8, and we take the standard value 40. Diameter of the boss, that is D2, is 1.6 d. So 1.6 into diameter of the shaft, that is, it comes out to be 64. Thickness of the boss T2 is 0.3 d. So 0.3 into 40, 12. Length of the boss 1.25 d, and it comes out to be 50. Now the diameter of the shaft at the center of the bearing, that is D1, is calculated by considering the shaft under bending and twisting. So apply the formula, that is P under root L square plus L square is equal to pi by 16 tau D1 cube. Put the value of shear stress, load, small l and capital L, and you will get the value of D1, that is 40, will be the same value. Now we have to find the dimensions of the key. For the diameter of 40 mm, the width of the key, you can see it from the table, or you can divide it by 4. So width of the key we have taken is 12, thickness is 8. So length of the key will be equal to the length of the boss. So twisting moment, that is T, torque is equal to L1 length of the key into W into tau into D by 2. So these are the formulas which we are repeating here from the chapter of coupling. So if you have any doubt, just go through the videos of coupling and keys. So put the value of W, shear stress and D by 2. You will get the length of the key 47.6. It may be taken equal to the length of the boss, so we can take it as 50. So in the last step, the dimensions of the rectangular arm at 60 mm from the center of the shaft. So let thickness T and B is the width of the arm, which is taken as 3T given in the question. So bending moment at 60 mm from the center. So bending moment will be load into distance. Load is 800 and the distance will be 1000 minus 60. So it is bending moment. Z is section modulus 1 by 6 TB square. Put the values. And bending stress or tensile stress 73 is M by Z. Put the values and you will get the thickness of the lever, and it comes out to be 20. So width will be 3 times T, that is 60. So width of the arm near the handle will be half, that is half of 60 will be 30. So this completes the design of hand lever and foot lever. Okay guys, thank you.